Alrighty, I was going to say lady and gentlemen, but lady seems to have left the room. So, gentlemen, good evening, and welcome to the Smart Tech Lab. I want to introduce you today to an idea that my team and I have been working on for the past 16 weeks, and it's the Modular Utility Tunnel Sensor, which we short call MUTS. What my team is not here, as you can see. Before you ask, no, they are not imaginary friends. They are all existing. What we did was we kind of tandemed this project between two classes. The class that I did this project for actually takes place in this very lab, and so I spent both time in this lab and as well as the other class and created the project along with these very capable people. What my project was to create a system that would detect underground utility environments such as electrical vaults, power vaults, steam delivery systems underground that would alert users or alert maintenance workers when certain parameters got out of hand. So if there was a pressure leak or if there's a natural gas leak or if there's some sort of other natural disaster that needs being averted to, these people would be able to find out the information they need and avoid potentially hazardous situations. Current systems do exist, but the problem with those systems is they're very sort of a high-level system. They're not very granular. So, for example, if there was a PSI drop in one of these vaults of under 100 PSI, you would not be able to detect that drop. 100 PSI is enough to severely harm a human being, and our system is capable of picking up a far more granular level of information. We were able to complete this by using a various skew of tiny little pieces that we put together. We experimented with the Arduino, but we found that it was not powerful enough for our needs. So we ended up going with a Raspberry Pi, which automatically gave us built-in Wi-Fi capability, far more computing power, and also allowed us to use a wider variety of sensors to monitor the underground situation. So what we started off with was we thought, the basic things we should probably account for are temperature, humidity, and pressure. Of course, we can modify these based on your vault needs to go to natural gases if you need to, seismic movement if you need to, water levels for certain other things. If you've got a leak and you need to find out, we can always expand to that as well. What you see on the upper left-hand corner is a prototype board that our ECE team designed for us. That is a one-of-a-kind board, never before seen, and it was custom built for our application. So we had a couple of those printed off, and we have a live demonstration happening in the back, and I'll show you a little glimpse of that at the end of this presentation. And we used another multitude of sensors. The one you see on the lower right-hand side is our temperature sensor, and the one on the lower left-hand side is our pressure sensor, which comes standard in all of our models. So, problems, just like everyone else, we encountered prototyping. We got really ahead of ourselves and we thought, we should really do this and we should throw this and we should throw that. And before we knew it, 8 weeks had already gone by and we were kind of in a crunch. So we said, let's nail down a few things. So we all agreed temperature and pressure should definitely be standard. So we worked on that. Our budget was a little bit also of a constraint because we were not allowed to do as we please. If we had been, we would have had a much bigger and fancy looking machine, but we were kind of coded by that. Our coding was also an issue because we were spoiled for choice, as it were. We had a lot of options with the Raspberry Pi. We could have used Python, we could have used C++. The coding team eventually opted for Python for its shorter learning curve and wider flexibility, plus all the sensors that we got came with libraries that were pre-coded in Python, so that helped out a lot. And the circuit board itself, designing of the circuit board took about 12 weeks in itself. So that was really cutting it close to the wire. So we overcame all these problems, and we crunched out the cost and found that actually, thanks to our business team that helped us develop this, we were able to produce a fully working unit for $124. And the prototype that I'm passing out right now was what the class previous to us had worked on, and this prototype costs $425. So we were able to slash the cost fairly significantly by using newer parts and finding a mass supplier for the parts as well. So this cost would buy us, at this cost we could make 10 units easily which would be used across 10 different utility vaults. That's all. There's a few things that I wanted to go over before I end my presentation. I had developed a video, but I thought the live thing would probably be better. So I'm going to go ahead and launch that for you guys real quick. And what you're going to see on your left-hand side is our actual pressure monitor, which is behind me right now. And you're going to see a live feed of what the actual information is within the room right now. The pressure looks a little bit off, but I assure you it is not 99,000 ATM in this room. So what you see on the right-hand side is the server information, which then translates over into a nice little populated list. And this list will populate for every utility sensor that you carry or that you add onto your system. So you could have one in a particular vault, another in a particular vault, and each one will give you an output of your time, location, and current conditions as you apply them or as your vault requires them. I can set off a fault in the back here real quick, and you'll see on the other side. If you keep your eye on the temperature, you'll see a fault at temperature of 27 Celsius as soon as it gets there. And those faults will then be notified to your technician and let them know, hey, there's a temperature spike here, there's a pressure spike based on whatever parameters you need to set. The setup is running live and will continue to run live, so at the end of this, please feel free to come back and ask questions about it. And thank you very much for your time.